Let us look at principle number two. So I start again with my stable system. Everything is 100 minutes, so no waiting, very high utilization of 100%. Wow. So now let's change something. Okay, so let's make this, and in this system, what I'm going to do is, let's say I'm having a very expensive product or an innovative product, and I create a target that my waiting time for customers should not be more than 10 minutes. Okay, that's the target I have in my mind for this service. So I let's say start with creating some variability. My times vary from 95 to 105. There's still average is still 100. So we might think that, oh, still average is 100, service time is 100, so customers shouldn't wait. But if you look at averages, my customers are waiting. Okay, so 20 minutes, which is more than my target. So now what do? I put more people to do the work. I employ more people and reduce my service time slightly. I'm still going to assume uniform service times. I reduce my service time slightly, and then see what happens, because I'm now putting more people. Work can be done faster, or more people are doing it, whichever ways we look at it. So yeah, if you look at the times which are coming up, all are less than 10 minutes. Wonderful system, but our utilization has dropped from 100% to 99%. So somewhere my cost of providing the service goes up. Let's say there's higher variability. Okay, let's make it 80 to 120. If you see, I'm keeping the mean constant. The average is still 100, right? And with these times of 99s, I try to run it. Yeah, and oops, 47, that's too much. So let me try, let's say I tried 97. I don't know if 97 will work. I'm just trying different times and then find average. Nope, it don't think it'll work. It's still high. Let's put 95. Yeah, this seems to work. Yeah, it seems to work. Just about 10, but yeah. So on an average, some of them are higher, but fine. On an average, 95. So what happened now? I'm able to give good service, but my utilization has dropped. Let's suppose if this goes up, okay, and this goes up to 60 and 140. I have very high variability. And I find the averages again. Um, so again, like I said, if you're doing it in real life, you should simulate it for more than 10 times like I have, and use some other tools other than Excel. I use R for all my simulation needs also. So 46 minutes, too much. So maybe I can reduce the times to 92. Yeah, coming down. Works a little bit 17 higher, so maybe 90. So this is, again, we don't have a fixed answer, but that's how real life is. We'll rarely have fixed situations where we can put in a number. Things are variable, and the variability is not controlled. We don't know, or we don't understand the exact variability. Yeah, this seems to work. So now what happened is it worked, and with 86 my utilization is close to 85%. So if you see what's happening, this is the principle number two that I wanted to bring in, is that if I want to offer a certain service level as a business, as my customer variability or any kind of variability increases, I have to start planning to have a lower utilization. I cannot plan to have my employees always working. I have to plan to keep my employees idle, because that is the only way I can create a good service for my customers. And here, let's try to have some fun. Let's see if I can change my service terms from uniform to variable. So 80 to 120. Okay, so the average is still 100. This will create huge problems, I know, but let's find out. Let's find out what numbers does it bring it to. So it's 157 minutes, which is a lot. My utilization is very high, but so I'm going to try and reduce this to maybe 70 to 110, right? So I'm bringing the average service time. I'm planning for them to be idle for 10 minutes. Let's see what this does. Well, the service times are still very high, around 25, even though I plan for them to be idle for 10%. Let's say I plan to keep them idle for 20 minutes or 20% of the times. So this becomes, say, I need the average of 8. So 60 and what, 120? Yeah, sorry. 60 and 120 planned is 90. Yeah, let's plan for 85. Let's see what happens when I shoot for 85. So I'm planning to keep them idle for 15% of the times. Well, even then it's higher. So now I plan to keep them idle for more, maybe reduce this time to 100. So this average, I'm keeping them idle, plan to keep them idle for 20% of the times. Yeah, somehow this seems to just work. It's higher, but it works. So what happened is when there was variability in both sides, in the previous case, if you remember, when service was stable, if I kept them idle 15% of the times, it worked. But now I have to plan to keep them idle for 20% of the times. So that's the idea of how damaging variability is, that to offer certain service level, as the variability increases, businesses have to plan for lower utilization. So general statement, any service, if we want to control customer wait times, we will have to plan for and aim for customer lower employee and lower resource utilization.